As we said, one problem with the O of 1 scheduler in Linux is that once tasks are placed on the expired list, they won't be scheduled until all remaining tasks from the active list have a chance to execute for whatever their time slice amount of time is. As a result, the performance of interactive tasks is affected. There's a lot of jitter. In addition, the scheduler in general doesn't make any fairness guarantees. There are multiple formal definitions of fairness, but intuitively you can think of it that in a given time interval, all of the tasks should be able to run for an amount of time that is proportional to their priority. And for the O of 1 scheduler, it's really hard to make any claims that it makes some kind of fairness guarantees. As we said, Ingo Molnar proposed the Completely Fair Scheduler, CFS, to address the problems with the O of 1 scheduler, and CFS is the default scheduler in Linux since the 2.6.23 kernel. It's the default scheduler for all of the non-real-time tasks. The real-time tasks are scheduled by a real-time scheduler. The main idea behind the Completely Fair Scheduler is that it uses a so-called a red-black tree as a run queue structure. Red-black trees belong to this family of dynamic tree structures that have a property that as nodes are added or removed from the tree will self-balance itself so that all the paths from the root to the leaves of the tree are approximately of the same size. You can look at the instructor notes for a link for more information about this type of data structure. Tasks are ordered in the tree based on the amount of time that they spend running on the CPU, and that's called virtual runtime. CFS tracks this virtual runtime in a nanosecond granularity. As we can see in this figure, each of the internal nodes in the tree corresponds to a task, and the nodes to the left of the task correspond to those tasks which had less time on the CPU. They had spent less virtual time, and therefore they need to be scheduled sooner. The children to the right of a node are those that have consumed more virtual time, more CPU time, and therefore they don't have to be scheduled as quickly as the other ones. The leaves in the tree really don't play any role in the scheduler. The CFS scheduling algorithm can be summarized as follows. CFS always schedules the task which had the least amount of time on the CPU, so that typically would be the leftmost node in the tree. Periodically, CFS will increment the VRun time of the task that's currently executing on the CPU. And at that point, it will compare the virtual runtime of the currently running task to the VRun time of the leftmost task in the tree. If the currently running task has a smaller VRun time compared to the one that's in the leftmost node in the tree, the currently running task will continue executing. Otherwise, it will be preempted and it will be placed in the appropriate location in the tree. Obviously, the task that's corresponding to the leftmost node in the tree will be the one that will be selected to run next. To account for differences in the task priorities or in their niceness value, CFS changes the effective rate at which the task's virtual time progresses. For lower priority tasks, time passes more quickly. Their virtual runtime value progresses faster, and therefore they will likely lose their CPU more quickly because their virtual runtime will increase compared to other tasks in the system. On the contrary, for high priority tasks, time passes more slowly, their virtual runtime value will progress at a much slower rate, and therefore they will get to execute on the CPU longer. You should take note of the fact that CFS uses really one run queue structure for all of the priority levels, unlike what we saw with some of the other scheduler examples. In summary, selecting a task from this run queue to execute takes O of 1 time, takes constant amount of time since it's typically just a matter of selecting the leftmost node in the tree. At the same time, adding a task to the run queue takes logarithmic time relative to the total number of tasks in the system. Given the typical levels of load in current system, this log of n time is acceptable. However, as the compute capacity of the nodes continues to increase and systems are able to support more and more tasks, it is possible that at some point the CFS scheduler will be replaced by something else that will be able to perform better when it comes to this second performance criterion.